I'm Sarvesh, and this is NeuroMap. It's a tool that turns natural language descriptions of neural circuits into real mathematical models that you can simulate and interpret. Computational neuroscience often starts with simple ideas like this neuron excites that one, or this pathway forms an inhibitory loop. Turning those ideas into differential equations and simulations is difficult. NeuroMap makes modeling as easy as describing the idea itself. Now this is the main input panel. You describe the circuit in plain language. For example, I entered three neurons, N1 excites N2, N2 inhibits N3, and N3 inhibits N1. Use rate-based units. NeuroMap will treat this as a complete model specification. Now when I click Generate Model, NeuroMap converts the text into a structured connectivity graph and a set of rate-based equations. You can see the actual equations here along with the weight matrix. Positive weight represent excitation, negative weights represent inhibition. Everything is transparent and editable. Next, I set the simulation parameters and I will now click Run Simulation. NeuroMap uses a deterministic ODE solver to integrate equations over time. The plot shows the activity of each neuron. You can see how the inhibitory loop shapes the dynamics. One neuron stabilizes, one dominates, and one is strongly suppressed. Below the plot, NeuroMap summarizes the behavior of each neuron. It shows the mean activity of the final value and basic stability indicators. These metrics help users understand how the circuit behaves without needing to inspect raw data. Now, when I click Interpret Results, NeuroMap sends only the validated parameters and a summary statistics to an AI model. The model returns the scientific explanation of the circuit. For example, it might say that the circuit produces a stable pattern where N2 maintains the highest firing rate, N1 remains moderately active, and N3 is suppressed due to its inhibitory chain. NeuroMap lowers the barrier to computational neuroscience by turning natural language into real mathematical models. Built in 48 hours for Impact Forge, NeuroMap shows how AI and classical numerical methods can work together to make neural modeling accessible, transparent, and powerful. And that's my project. Thank you.